Good afternoon, everyone. I'm Anand, Buddhdev at the RIPE NCC, as Keith has just introduced me. And my role at the RIPE NCC is usually in the DNS area. And that's always fun to talk about, but there's other stuff that I've been playing with lately. And I think I'd like to tell you all about it. And that thing is called Ansible. Just before I start this presentation, I'd like to quickly mention something called RACI. That's the RIPE Academic Cooperative Cooperation Initiative. And this is an initiative by the RIPE community to invite and encourage people in academia to come to RIPE meetings and present and talk about their work. If you're an academic or doing research in the internet area, you are encouraged to apply to this initiative. And if you are selected, then the RIPE community or the RIPE NCC will fund your travel and assist you to come to this meeting and talk about your research. The deadline for RIPE 68 in Warsaw is 25th April. And if you submit your applications after that, then you will be considered for RIPE 69 in London. Okay. So what is Ansible? Well, it's actually a theoretical or a fictional machine. It's capable of instantaneous communication. And you might have seen something like it in Star Trek movies and series. It's the little thing that Captain Kirk uses to talk to whoever on the ship, Uhura or whatever. It doesn't matter how far away they are. They seem to be able to communicate in real time. And that's what an Ansible does. But such devices don't really exist. But there's an open source project now, and they've given it the name Ansible. I think they're trying to achieve some of its features, and maybe they're getting there. It's an IT automation tool. So a lot of you are probably familiar with stuff like cfengine and Puppet and Chef. And Ansible is just another one of them. It differs from it differs from cfengine and Chef and Puppet in a few ways. And that's what I'm here to highlight. It's actually very, very good for one-time tasks that you might want to run against one or more servers. So the thing about things like Puppet and cfengine is that you have to define these policies and then push them out to a node, and you need an installation of cfengine or Puppet on that local, on that managed node to actually do things, whereas with Ansible you don't have to. You can use Ansible to configure systems, push out configuration files, change aspects of the configuration, and you can use it to maintain state. So for example, if a certain application should be running on a system, then you can use Ansible to make sure it is. Ansible is written in Python. Now this is a very nice thing. I don't know if any of you have ever used something like cfengine. cfengine is written in C. And it's very difficult to read and write, because a lot of us are network engineers or sysadmins, and we're not programmers. So it's very, very difficult to try and extend cfengine, for example, to do things, extra things you might want to. But Python is much easier. A lot of us sysadmins, network guys may actually know some Python, and it's easy to extend to Ansible with Python. It's open source software. There is a commercial company behind it offering support, but it is completely open source. It's hosted on GitHub, so you can look at it, you can download it. If you have a new feature that you've developed, you can merge it back into the main tree, issue a pull request. And the developers are quite happy to receive patches and new features to integrate into Ansible. It's very, very easy to install. You can get started in as little as 2 minutes on your laptop. It's that simple. And the beauty about it is that it will scale from just a handful of systems up to thousands or thousands of servers if you wanted to. So you can use it on a small scale, or if you're a large company, you can also use it to manage your server farms. It has very modest requirements. You need on your management station Python, because it, of course, written in Python. And it makes use of a number of Python modules, such as Jinja, which is a templating engine, Markup Safe, which is a dependency of Jinja, PyYAML, which parses YAML files, and optionally you need Paramiko, which is an implementation of SSH in Python, and then you need PyCrypto if you have Paramiko installed. However, if you have OpenSSH on your system, you don't even need Paramiko, because Ansible can make use of SSH to connect your managed hosts and perform actions on them. So installation of Ansible is very, very simple. On any OS that you might have, you know, whether it's Mac OS X, Linux, FreeBSD, whatever, most of them come installed with Python these days. And you can use something called virtual env to create a sort of standalone, isolated installation of Python. And in there, you just run pip install Ansible, and you're ready to go. It's as simple as that. If you're on a CentOS or Fedora type system, you can also enable the EPEL repo, and then use yum install Ansible, and you're ready to go. So in 2 minutes, you can start using this tool. Ansible consists of a few different programs. Ansible itself, a tool called Ansible Doc to view documentation, Ansible Galaxy, which I will mention later, Ansible Playbook, which is useful for running lots and lots of tasks together, and Ansible Pull, which I will also talk about later. And the other component of Ansible is its module library. Modules are the actual workhorses of Ansible. They do things on a system. So you have lots and lots of modules, for example, to add and remove users and groups to a system, to install packages with yum or apt, to manage cron, you know, to manage, to copy files over, to start and stop services, etc., etc. So these modules are what actually get things done. Another component of Ansible is the inventory. Now, this is very important. This is simply a file containing all the hosts that you would like to manage using Ansible. You can also use this inventory to group hosts together, for example, hosts that have a logical function, and you can put these inside the inventory. The inventory can also be a directory, in which case all the files in that directory are simply concatenated, and the names of the files become group names. And if you so wish, the inventory can also be an executable program, which should output the inventory on standard output. So for example, this executable could query, you know, a SQL server or an LDAP server and output your inventory. So it can be a dynamic inventory. So here's an example of an inventory file. The usual location is /etc/ansible/hosts. And I've listed 4 hosts in there, AWS 1 up to 4. These are just little Amazon EC2 instances that I've fired up for, you know, the purposes of this presentation. If you're not able to read the slide on the screen, you can open the same presentation on your laptops to follow the slides along. In this inventory, you can also see that I've defined 3 different groups: DNS servers, web servers, and mail servers. And the hosts that should perform those functions are listed under the group names. So how do you run Ansible? Well, it's very simple. You can use the Ansible program. You tell it which hosts you want to perform actions on. You give it a module to tell it what you want it to do. And you pass it some parameters. So one of the modules that ships with Ansible is called ping. This is one of the simplest modules. All it does is it makes an SSH connection to the host or hosts you specify. And if it can connect over SSH, it comes back with pong to let you know that it has successfully managed a connection. So if I run Ansible all -m ping, then I'm saying to Ansible, do a ping against all the hosts in my inventory. And it connects to all of them over SSH in parallel, and then prints the results on standard output. And in this example, you can see that it's come back with success for them all. So it managed to connect to all of them. In order to speed up Ansible runs, Ansible actually makes connections to hosts in parallel. The default is 5 parallel connections at any one time, but if your laptop or your management workstation can handle more, you can increase concurrency up to 10, 20, 100, whatever. So here's an example of running Ansible against just one host. So instead of saying all, I say Ansible space AWS1. So I'm addressing one host here. I'm using a module called command, which runs a command on the remote system. And the parameter I'm passing it is who am I. And if I run this, Ansible connects to this host, runs who am I, and prints the results and standard output on my management laptop or workstation. Now, suppose I want to perform an action against a group of servers, say my web servers. I'm interested in seeing a long listing of /etc/password. Then I run Ansible space web servers. So I address all the web servers in my inventory. You'll notice I don't have a module name here. If you don't specify a module, then the default module is the command module. The parameters are ls-l/etc/password. And the -o option says print the results on a single line. That's just for compactness. And Ansible goes away, makes 3 parallel connections to all the web servers, comes back with the results, and they're displayed. So you can see it's very, very easy to get started with Ansible, and you can use it to manage some hosts that you might have. Now, you don't have to have a large server farm to use Ansible. Lots of us have small numbers of hosts in our data centers, personal machines, etc. You can use Ansible to manage these machines. So here's another example. I want to install a package on all my hosts. The package name is screen. So I call Ansible and address all hosts. I use a module called yum, which knows how to run the yum command on CentOS and Fedora-like systems. And I give it the parameter, package name, screen. And I've also specified another command line option, -s, which says use sudo. So Ansible will connect to all these hosts, run yum, install screen, and display the results. In this case, you'll notice that when it ran against the 4 hosts, it came back with 3 of them and said changed is true. And for one of them, the changed the change parameter was set to false, which meant that Ansible did not actually have to do anything on that host, which means the package screen was already installed on this host. So this is one of the features of Ansible. It's called idempotence. If you run it against all your hosts and you ask it to perform a change, if that change is not required, then Ansible does nothing. So you can safely run it as many times as you like against all your hosts without worrying that something unexpected will happen. Here's another quick example. I address all the DNS servers in my inventory. I use the yum module and say install NSD. Then I go away and say Ansible, address all DNS servers, use the copy module, and copy a file called nsd.conf from my management workstation to /etc/nsd/nsd.conf. And finally, I say Ansible, address all DNS servers, use the service module, and make sure that NSD is running. So in 3 commands, I've installed NSD on all these DNS servers, I've copied over my config file, and I've made sure that NSD is running. Now this becomes a bit tedious because you have to run all these commands over and over. So here is where we come to playbooks. Playbooks are recipes of what to do and on which hosts. Basically, they collect Ansible commands into one file and then allow you to run that file in one go. Ansible playbooks are formatted in YAML, yet another markup language. It's very easy to read and write and keeps things simple. It also allows you to set variables, for example, which you can't do on the command line. It can contain handlers to take actions on a system after copying files or making other changes, and it's reusable. Here's a sample playbook. I've called it httpd.yaml, but it can be anything. And in there, I've got a dictionary, a YAML dictionary. I'm addressing all the web servers. I'm saying use sudo. And then I've got 3 tasks defined, which install httpd. They copy a config file and make sure that it's running. And I've also got a handler which says restart httpd in case the httpd.conf file has changed. So executing a playbook is as simple as calling Ansible-playbook and then giving it the playbook name. And Ansible will connect to all the hosts that have been addressed in it and go away and perform all the actions in the playbook and come back with a recap of what it did or what it did not do. I mentioned idempotence earlier. So here I've run that same playbook again against all the hosts. And if you look at the end where it gives a recap, you'll see that it actually did nothing and nothing was changed. So it's safe to run as many times as you like, over and over. You can also limit your playbook runs to specific hosts in your inventory using the lowercase l option. So here, for example, I have an example saying Ansible playbook httpd, but I'm limiting it to only one host, AWS1. So even though all hosts are addressed in the playbook, for this specific run, I will only address one host. Ansible also allows you to use templates, and it uses the Jinja templating engine for this. Templates are very powerful because you can use placeholders in them to substitute variables. They give you loops and conditionals, and they provide you filters to transform text from one form into another. And what Ansible does is it also makes facts available to Jinja. Facts are all kinds of things about a system. Variables, interfaces, packages installed, file systems, etc., etc. And these are made available to the templating engine so it can make use of them. Here's an example. I have a playbook. Hosts are DNS servers. I've set a variable called nsdprox to 8. And I've defined a list called zones, inadder.arpa and ip6.arpa. And then I've got a task which is going to take a template called nsd.conf.j2 and stick it into the destination/etc/nsd. And here's what the template looks like. So I'm running short on time, so I'm not going to run through the entire template. But essentially, it uses for loops to generate some config for NSD. And it's making use of these variables defined earlier in the playbook. Ansible also has a feature called roles. Roles is where you can collect things like playbooks, tasks, variables, and put them into logical groups so that you can reuse roles together. So for example, I could define a role called MySQL. It could be a role for MySQL servers. Roles are structured in directories, and inside a role directory, you can have files, handlers, variables, and put your files in there. And this also allows for easier organization of your playbooks and stuff. So inside a playbook, instead of calling tasks, you can actually just give your host names and define which roles will be associated with those hosts. And then the playbook will extract the relevant tasks from all the roles and apply them to all your hosts. So we've so far seen how Ansible can be used in this push mode where you have a management workstation or a laptop. You install Ansible on it. On the nodes that you want to manage, you don't need anything except Python. And what Ansible does is it connects to all these hosts. It transfers all the Python modules it requires, executes them locally, and then deletes them. So it leaves no stuff lying around on your target systems. It's very lightweight. You can get started instantly. It works very well for small numbers of hosts. If you have 5, 10, 20, 30, or 40 hosts, it'll work just fine. You can instantly write new playbooks and use them right away. But the trouble is that if you have hundreds of hosts, then this is not going to scale because your management workstation will need to connect to all of them and execute your playbooks. and this could take time. Or your host could be unreachable or offline for some reason, and then they will miss their configuration window. And you need to run this periodically if you want to maintain state. If you want to make sure that an app should be running, then you need to run them. So there's another mode of Ansible called local mode, which is where you can actually copy your playbooks onto a host and then run Ansible locally on the managed host. Now, this, of course, requires that you install Ansible on your managed host. So this is a little bit more involved. It needs you to set things up. And in this mode, Ansible behaves a little bit like cfengine or Puppet because you are installing Ansible locally, and it's going to run on these hosts. And then when you run a playbook, you pass it another option called -c local, so that it doesn't actually make any SSH connections anywhere, but just executes a playbook locally. And this scales very well. You can have your playbooks copied to hundreds or thousands of hosts, and even if that host is disconnected, it will continue to maintain state. So in this case, it works almost like cfengine or Puppet. So at the RIPE NCC, we are using Ansible, and we're using it in this pull mode. Our entire Ansible setup is inside a Git repo, and it consists of a portable Python Ansible distribution, and the same distribution is copied to all the nodes using rsync. Ansible runs locally on the managed hosts, but the beauty about this is that because it's in a Git repo, any of our operators can check it out onto their laptops and also run Ansible in push mode against these hosts. So we can push and pull, and it achieves the exact same effect, which is great. We have two playbooks in there. One is called Bootstrap, which just needs to run one time for every host to set it up initially with a few things. And then the main playbook, which runs every 10 minutes or so. And this maintains state on the system. So I talked about Bootstrap. And in order to get these playbooks out, we have a distribution server, and it runs rsync, and all the managed nodes rsync the playbooks from it. Ansible runs locally and logs to varlog Ansible and maintains state, as I mentioned. A few things that need improvement to this setup, which we're working on, is rsync level ACL, so that we don't have to copy all the playbooks to every host. So for example, DNS servers don't need MySQL configuration, so we can skip that. And at the moment, there's no active feedback from Ansible running locally, so we don't know what it's done. But there are things called callbacks in Ansible that we can call to give us feedback. And we haven't defined any yet, but we're working on them. So that's the end of my presentation. We're running short of time, so if you'd like to ask me questions, you can come and see me later. If there's any general question, we could maybe take one.
We have room for one question, and I think Dave just grabbed it.
Hi, sorry, Dave Friedman, Coronet again. Just very quickly, you mentioned a number of other configuration management systems, such as Puppet, Chef, and whatnot. What were your experiences with those, very briefly, and why did you come to the conclusion that you needed this?
We've used cfengine in the past. As I mentioned, it's written in C. It's got bugs. When we find bugs, we have to report them upstream. They don't get fixed. We can't fix them. Getting to the source code is difficult. And cfengine doesn't ship with a nice library of modules to do things. You have to define a lot of things yourself. cfengine is like the C of programming. You end up redoing a lot of stuff that that people have already done.
But I think putting cfengine aside and looking at the more modern configuration management systems like Puppet and Chef, which are quite mainstream,
yes.
Why? Why Ansible?
Ansible differs from all of them in that it has this push mode, which we like, because even if you're not using it to manage Ansible, even if you're not running it in local mode to manage hosts, you can also use it for lots of ad hoc tasks, which I showed earlier. And that's great for light, quick sysadmin tasks, which none of the others provide you with. Okay.
I think Puppet and Chef both do that now.
Okay.
Okay. Anyway, thank you.
All right, cheers.
Okay, thank you very much, Anand.